All right, good morning, everyone. I hope you guys had a nice weekend. So, any questions before we start today, our last week? Any questions? Okay. Did you guys have any problem connecting? Or you connected immediately? No answers, okay. Right, so we start. So we're working now with polar coordinate. I will quickly remind you the basic, the definition of it, and then we proceed. Okay, so polar coordinate is actually another way of locating points in the plane beside the Cartesian. That's the idea, that will be extremely useful to represent some region in the plane, which I will definitely point out today. So our basic definition was we took a point, we call it a pole, and we took a line that is the same as the positive x-axis, and it's called the polar axis. And we located a point in the plane as follows. Okay. We took a point, any point in the plane, and the way we located it is by giving you two pieces of information. The first piece of information is the angle that the point, so this is my point P, is the angle that the point formed with the positive x-axis. And first we said the distance from the point to P. And then we extended, so R, the first definition was R is the distance from O to P. And theta is the angle between the positive x-axis and OP. And then we extended this definition to the following, whereby to allow R to be negative. And the way we extended it, we said that if R is negative, then the point with coordinate minus R theta is basically the point which is opposite to R theta. So if R theta is in the first quadrant, minus R theta will be in the third quadrant, and so on and so forth. So we extended the meaning of R to allow R to be negative. And then one thing probably I forgot to mention last time, if R equal to 0, this corresponds to the origin right there. So if I write 0 for pi, it doesn't matter what theta is, R equal to 0 corresponds to that point. So I'm going to sketch 2 points in polar coordinate before we proceed. So let us say I'm going to sketch the point 4, 2 pi over 3, and minus 4, 2 pi over 3. So just to make sure we understand this negative R. So 4, 2 pi over 3 is simple. We start from here, and we take an angle, 2 pi over 3, and we go 4 units from here. That's my point. So this is my R, and this is my angle. So that's the point with polar coordinate. So we have to be very careful. That's polar coordinate 2 pi over 3. Now, what is the point minus 4 2 pi over 3? In which quadrant is this point going to be? Quickly, I want answers so I can proceed. In which quadrant this point will be? Chat is open for you. Chat is open. I want answers on chat. If I want to sketch the point where R is minus 4, the angle is still 2 pi over 3. In which quadrant? Bottom right, or we can call it, if you want, you're absolutely right, Sarah, the fourth quadrant. So we can really. So if you take this and you go this way. That's the point. In polar, minus 4 2 pi over 3. So the negative R is nothing more than the point in the opposite quadrant, if you want, totally opposite to 4 2 pi over 3. And then we talked about the idea that in polar coordinate, a point can have different representation, not only one. In Cartesian, and that's an important difference, every point have one representation in Cartesian. In polar, it can have another one. So who can give me another representation of this point with a positive 4? I want an answer quickly. I want another representation of the same point, but I want the R to be positive. So basically, I want the angle right here, what is going to be. Please, I want answers on chat, or I want you to speak it up. Okay, 5 pi over 3. All right, let's see where she got it from. So what did she do? What I think she did is she told me it's 2 pi over 3, and then you add a whole pi to your answers. So that's what give me. So I will write it in terms of 2 pi. So it's 2 pi over 3. I will add to it a pi. And that's what give me the exact same point. So a point in polar coordinate have a lot of actually representation, not one, not two, it has infinitely many, because I can also give it the following representation. 2 pi over 3 plus pi, which is 5 pi over 3. And then I can start adding a bunch of 2 pi's, which will not really change the point, and so on and so forth. Okay, the last thing we've started talking about is that if the following, so the last idea we've talked about is the following. So if I have the polar, my polar axis, and on the top of it, I'm going to put the x and y axis. So here, so this line for me, this is the origin, this is the x axis and the polar axis at the same time. It means the polar axis means that from where I should start to measure my angle. So that's important. And that's my y-axis. And then the idea was I take a point in here, and this point will have two different coordinates. It have xy coordinate, the Cartesian one, the one that we are very much used to, and it has the polar one. The polar one are r and theta. And the question that I've addressed to you last time was the following. If I know the r and the theta, I know this, I know that. Do I know what x is and y is? And using the point P in the first quadrant, and using our trigonometry, what I mentioned last time was the following. The cosine of theta, the cosine is this side over r. And the sine, just using basic trigonometry in the right triangle, is the y over r. And from this, we found the following relationship. So this is from polar to Cartesian. Okay. And what was the relationship? That if I know r and theta x, so if you ever forget this relationship, we can somehow come up with it in a simple scenario. So x is r cosine theta, and the y is the r sine theta. All right. But here's the thing. To show you that, I only used the point P in the first quadrant, basically. It means I took r positive and I took theta between 0 and pi over 2. Otherwise, because I used the idea of a right triangle. But what we can show, and it's not really hard, that the same formula hold, the same relationship hold, regardless where theta is. It means it will hold if theta is in the second, fourth, fifth quadrant, regardless what theta is, and it holds whether r is positive or negative. So even though I showed you the relationship in a very restricted area, to be able to use, to help you to memorize the relationship, so I only use P, but this will hold regardless where theta and sine theta is. And why it holds, I will mention a few words about that. because of the definition of sine theta. If you guys remember the unit circle definition of sine and cosine, if you remember the unit circle definition, if this is the unit circle and this is the angle theta, what sine theta and cosine theta means in general, they are the x and y coordinate. So this is the cosine, this is the sine, and this is the cosine, if we are on the unit circle. Now, if I am moved and I am on a larger circle.
I really needed to know this. Oops.
Okay, if you are on a circle of radius r. So what it will happen to the points, if I take this point and I stretch this right there, it means I'm going to allow this to be r. So what will be, and I take this point, what will be the x and y coordinate of this point? That's the y and that's the x. But now by using the similar triangle ideas, this is the unit circle. Means if I stretch this hypotenuse by r, this side will have to be stretched by r. So this would be the r cosine theta. And that's really why those are holding all the time. It's they really go back to the definition of sine and cosine on the unit circle. And this will be the r sine theta. So the reason they hold is because the definition of sine and cosine. There is no other reason why those hold, even if theta is anywhere in the plane. Okay, so I showed it to you here to help you memorize it, but it holds in general because of the definition of sine and cosine in the unit circle. That's why it holds all the time. Okay, this being said, so we go back and write those relationships, and we do one simple example because going from polar to Cartesian is actually a very simple process because you just apply the formula. So I will rewrite those again, and I put the notes on Blackboard so you guys can actually use the notes. So the relationship is, I want absolute memory of those relationships. X is r cosine and y is r sine. You ever forget them, you have the two to remember them. Remember them in the simple scenario of that. And then remember that I told you they hold for every theta, and I told you exactly why, because of the unit circle definition. So this is r cosine theta, and this point right here is r sine theta. Very good. So let's take a very, very straightforward example. So for example, fine, I give you the polar coordinate. So the polar coordinate, polar of a point is, let's say, I don't really, r is 4, for example, and 2 pi over 3. It doesn't matter what I put. I can put -4. It doesn't really matter. So find the Cartesian. So I personally, and I advise you, always draw your point. So if you get answers, answers make sense. So 2 pi over 3, it means I am right here in this quadrant. 4, it means I am 4 units away. So that's really my point. So that's 2 pi over 3, and that's the 4. I actually want this coordinate, and I want that coordinate. So it's fairly simple, extremely useful formula, absolutely crucial. So the x component is going to be 4 cosine 2 pi over 3. And the y is going to be 4 the sine of 2 pi over 3. And now we try to remember a little bit our trigonometry. Now, of course, we know that the x has to be negative because we know exactly what we're following. And if my memory is correct, and that's going to be -1/2, which is going to give me a -2. And the y, the sign is a positive, and I think it's the square root of 3 over 2, which will give me 2 square root of 3 over 2. So those points here, this point here is 4 sine. I keep rewriting it because I really want this to be very, very, stuck in your mind. And this is the cosine of 2 pi over 3. Okay. So from polar to Cartesian is easy. You apply the formula. So now for the calculation part, can we use a calculator? Yes, Adam, but yes. Now we're gonna move the other way. So anyway, suppose I tell you you cannot use your calculator. Calculator is with you. If you were in class, I can control that. Now I don't have control over this. So yes, you can. Now part 2 is from Cartesian, from Cartesian to polar. It means I have my xy, and so again I will use the first quadrant because we can work with it easier. So I have my xy, so I know my x and I know my y, and the question is I need my theta and I need my r. Okay, so first let me find the r. Is it easy, the r? If I know the x and I know the y, can I find r easily without even memorizing? But you will memorize it. Can you find the r easily? Pythagorean theorem, always to the rescue. It will give me that r squared, because r is the hypotenuse, is x squared plus y squared. So I can pull r immediately from here. Now theta. How can I find theta? So if I know x and y, how can I find theta? So basically, you can use anything you want. Theta is an angle. You can use anything you want to find theta. You can use sine theta. You can use cosine of theta. Basically, you really have a freedom of using anything. So one of the common things people use is the tangent theta. So the tangent theta is equal to what? According to my picture. This is the hypotenuse. This is y. This is x. Tangent theta is y over x. So this will give me the tangent. Now, if I know the tangent, do I know the angle? Back to you. If I tell you I have an angle, I know what the tangent is. So I know what the angle is. And how do I find it? If I ask you a separate question, I tell you, okay, whatever. I tell you tangent theta equal to 1/2. Okay, and I ask you what's theta. All right, Lori said inverse tangent, arc tangent of 1/2. Is she correct? Absolutely so, but there is an issue with that. What is the issue? So before I go back to my note, let me tell you what the issue is, because you have to know it before I proceed. I don't know why I did this to the paper. Okay, so suppose I give you the following. I tell you theta is between 0 and pi/2. Tangent theta is 1/2. So what is theta? Okay, now of course I have to go back to my calculator and I find arctangent. So I find arctangent, tangent inverse of 1/2. So my calculator is in, no, I think my calculator, no. All right, I'll keep it in degree mode just because it's easier for you for now, but then I will change it. So it's 26 degrees. And 26 is between 0 and pi/2, so we're fine. So theta is arctangent, 1/2. It's fine. Now, let us say I tell you theta is between, I'm going to change tiny bit. Theta is between pi and 3 pi/2. And tangent theta is 1/2. Okay? Will this answer be accepted? Can I take theta to be 26? And that's the problem we're going to face, but I want to address it initially. So remember the graph of arctangent? The graph is periodic of period pi. It means the graph repeats itself. So that's pi over 2. The graph repeats itself, 3 pi over 2. The graph repeats itself. So 3 pi over 2, 5 pi over 2. So it repeats itself every pi. It repeats itself every pi. It's periodic of period pi. So now I want an angle between pi and 3 pi over 2. So that's 3 pi over 2, that's pi. I want the angle between 3 pi over 2 whose tangent is a half. So basically I'm after that angle. Now, the calculator, when you compute tangent inverse, it doesn't give you every possible angle. It only gives you the angle between minus pi over 2 and pi over 2. So the calculator, this 26 degrees, which is 0.0 something in radian, that's what the one that the calculator gives you, the tangent inverse of that. It gives you the one between minus pi over 2 and pi over 2. If I'm interested in the one between pi and 3 pi over 2, what should I do? Back to you. Remember, the calculator does not give me all possible angles. It gives me one, the one between minus pi over 2 and pi over 2. So if I want the one between pi and 3 pi over 2, I have to add a pi. Absolutely crucial. So we were going to use this, but we have to be very careful where my angle is. So in this case, my theta is not only the arctangent, is the arctangent of a half. You have to add pi to it. That's how we are gonna, that's why we have to be very careful where my theta is. So now I go back to what we were doing and explain it, work on it again. So what is the tangent theta equal pi over x, y over x? So where is theta? And really gonna depend on which quadrant theta is. The calculator only gives you the angle from here to here. If the angle is here, it doesn't give it to you. It gives it to you up to a pi. So the theta is going to be the arctangent of y over x, as long as my point is in the first quadrant and the fourth quadrant, because that's where my theta, that's what my calculator will give me. Anything between minus pi over 2 and pi over 2. If I'm not in this, then the theta will have to be the arctangent. We're forced to add the pi. And then I will get exactly my answer. So I will do 2 problems along those lines and then we proceed. So for example, I'm going to give you point in polar and the question is to find them, in Cartesian, and the point is find them in polar. So find the polar coordinate of the following point given in Cartesian. Find the polar coordinate of the following point given in Cartesian. Okay, so we're going to do that. I'll pick 2 points. So those are in Cartesian. So I'm giving you the x and the y. So let us pick, I don't know, 2 for x. And I will pick for y, let us say 1. Yeah, I put 1 or 5. It doesn't really matter what I pick. So this is in Cartesian. So this is the x and this is the y. In Cartesian, we have to be very careful what we're doing. The first step in this process, the absolute first step here, and it's important, is to draw the point. So 1, 2, 3, 4, 5. Because I really want to know which, so this is my point. So I am in the first quadrant. So that's my point, 2, 5. Okay, and I need to find the r, and I need to find the theta. Okay. So first the r. Now this is simple. R squared is 4 plus 25. This is 29. It means r is the plus or minus, but I will take the positive r, just because it's easier to understand. Now the theta. This is the theta. Theta is the angle between the positive x-axis and the line OP. you have to be very careful where theta starts. That's why this is called the polar axis. This is exactly from where we start measuring our angle. That's exactly what we start. So basically, you want to find theta. And honestly, I don't care what you do to find theta. You can do anything you want. If you want to use the sine, you'll be my guest. You want to use the cosine, you will be my guest. I want theta. So because I know those two, that's why books are using the tangent. Every book uses tangent simply because we know the opposite and we know the adjacent. That's why they are using tangent. If you want to use the sine, you're welcome because I know the hypotenuse. So you have really flexibility. I want theta correctly. That's the bottom line. So if I use the tangent, it's the y, which is the y over 2. Since I am in the first quadrant, the arctangent will give me the exact value. So arctangent of 5/2. So I will pick it up. I will pick it up in radian and in degrees. The degrees because we understand it better, and in radian because calculus work with radian. So I will pick it up first in radian. And I want that's easy, the tangent inverse of 5/2, which is 1.19 radian. And if I want it in degrees, you can either do it by hand or you can enter it. So let's do it by hand now. So tangent inverse of 5/2 is almost 68 degrees. Okay, and it makes sense. This angle is between 0 and pi over 2. Okay. Now I took another problem. So that's problem number 1. And problem number 2 is, suppose I take the point 2 minus 5. Okay. And again, the first step, that is now 2. The first step is to draw the point. 2. Sorry, I don't want 2 minus 5. My apology. I want minus 2 and 5. So this is my x, and this is my y. This is the point I want. So minus 2 and 5. So minus 2 and 5. Okay, that's the point. So this is minus 2 and this is 5. I remind you, what I want is this angle and the r. You can do anything you want as long as you give me the angle theta. So you don't have to use the tangent by any stretch of the imagination. And I will mention that in a minute. So here r squared is the same because I didn't change the number. It's 5 squared plus minus 2 squared. Minus 2 squared is 2 squared. This will give me 29. So r is the square root of 29. Now theta. I will use the tangent and then I will make comment about, you guys can use anything you want. But first I will use the tangent because the book uses it and it's used a lot. It's 5 over minus 2. 5 over minus 2. It means minus 5/2. And if I only use, so suppose I only write theta, will this be correct? Will this be correct? Okay, let us check. I made you draw the point. If I go to my calculator and I will put it, I keep it in radian, in degrees for a second because you will interact better with it. And I compute the tangent inverse of minus 5/2. And what did I do? Sorry. So I compute the tangent inverse of minus 5/2. What do I get? I get a negative number. Now, it's theta negative in here. So if I use this, I will get in degree, I will put on the third line because I'm going to change to radian, minus. So will the answer, square root of 29 minus 68, be a correct answer? If you look at the picture, theta is not negative. Theta is between pi over 2 and pi. That's why this is an issue. So I cannot use only the arctangent of minus 5/2 just as a formula. It doesn't work. And the reason is the calculator will give me only the angle between minus pi and pi over 2, whose tangent is minus 5/2. But now I don't want this angle. I want the one between pi over 2 and pi. The only way I can accommodate to that is basically by adding the pi. And this is because the tangent is periodic of period pi. Now this would give me the angle I am really interested in. So this would be, according to the previous, minus 1.19 plus pi. That will be, and if I go to degree, I have to add 180 degrees. And now I will do minus 1.19 plus the pi, which will give me 1.95 radian. And in degree, I will have the minus 68.19 add to it 180 degrees, which will give me 111.81. And now my answers actually make sense. So the angle is 111.91, definitely between 90 and 180. So the polar coordinate would be square root of 29, that's the R. And my theta, I will pick up the region 1.95, and that's my theta. Okay, so it's simple, but the only thing you have to be careful with is which quadrant my angle is. If, wait, why we add pi again? All right, if I don't add pi, I get minus 1.19. Does this make sense? Is my theta negative? Yes or no? Question number one, no. So what is happening geometrically? I go back to the graph of tangent, and I will draw the graph of tangent. This is the graph of tangent. This is minus pi over 2 and pi over 2. And that's the graph of tangent. And the graph is periodic. It means the graph will repeat itself. So this will be 3 pi over 2. Now, when I compute arc tangent of minus 5/2, and I got minus 0.19. The calculator will not give me, there are a lot of angles. So this is minus 5/2. That's the tangent graph. There are a lot of angles that have tangent minus 5/2. There is this one, there is this one, and there is that one. Your calculator will give you the one between minus pi over 2 and pi over 2. That's the one that's given by the calculator. It doesn't give you everything, it gives you one value. But according to my picture, my angle is between here and here. So what is it, my angle? I had to add pi to figure out the one I am interested in. So that would be plus pi. This will be the angle that is between pi over 2 and pi, and it has tangent minus 5/2. So that's really the picture we rely on. Otherwise, you will get wrong angles. Okay. So now a small remark on the side. You don't have to use it, but you know the bottom line is to compute theta. So this is one way to compute theta. It's easy. It depends on, you compute the arc tangent, but you ask yourself which quadrant we're working on. 1, 2, the calculator will give you the exact answer. 2, 3, you have to add pi because the calculator will not give you the exact answer. That's why we have to use the graph of tangent. Now, another approach to this problem, if you want, you can use it, but you don't have to, is the following. Just use basically common sense, and we do it like that. So that's another simple approach. I say, okay, I want this angle. I want this angle theta. This is minus 2, and this is a 5. So another approach, you say, I want theta, and this is an obtuse angle. So let me find this little angle here, for example. Let me call this beta. And I want to find it just by using basic trigonometry. So I take this triangle and I draw it in front of me. This is my angle beta. That's another way to do it. You don't have, and this is a 5, and this is a 2. So I say if I can find beta, I can find theta. So this will be pi minus beta. So if you can do it this way. So what is beta? Now I can use my trigonometry, anything you want. So you can use sine, cosine, whatever you want. So I will use the tangent because it's clear. This is 5/2. It means beta is the arctangent because now I am working in a right triangle. It's 1.19. So theta is pi minus 1.19. End of the problem. Okay, that's another approach that you can do to the problem. It means you want this angle, and just so you go to this acute angle beta, and you say, let me use regular triangle to find it. So you isolate it, you use regular triangle to find it, and then you look at your picture. What's my theta? It's the pi minus that. Simple trigonometry, tell me it's 1.19 minus 1.19. So you can either memorize the idea of tangent, or you can do it by saying, it's simple trigonometry, let me do it. Okay. So this is the relationship between the x and y coordinate and the r and theta. So that's cosine theta, y equal r sine theta. Those are very easy to use. If you have the r and the theta, you can find the x and the y. Now to go, so that's polar to Cartesian, Cartesian to polar. R squared is x squared plus y squared. Tangent theta is y over x, and this piece to use carefully, because the arctangent doesn't always give me the angle I'm interested in. All right, any questions before I proceed, please? Okay, now we're gonna start sketching stuff. What do I mean by that? Suppose in Cartesian coordinate, I tell you sketch the graph of whatever, x squared or something simple, y equal x plus 1. Simple line. So what does it mean to sketch the graph? I mean, basically, you have to graph all the point xy that satisfy this equation. So that's what it means to sketch. So we take all the points that satisfy this equation, we go to the Cartesian coordinate, and we start plotting them. So we say that, okay, if x is 0, y is 1, if x is 1, y is 2, and we start plotting those points. Okay, that's really what it means to sketch the graph of this curve in Cartesian, all the points that satisfy this curve. Now we're going to do similar but different. Right now, what we're going to do is we're going to sketch polar curve. So it means we're going to have an equation that relate the polar coordinate to each other, not the xy coordinate. And we need to sketch all the points whose polar coordinate will satisfy this equation. So I will start with a very simple equation, and I will ask you to sketch the following equation. R equal to 2. What am I talking about? It means you have to sketch all points whose polar coordinate satisfy the condition R equal to 2. So Cartesian, sketch y equal x plus 1 means sketch all the points whose Cartesian coordinates satisfy that. Polar curve, it means I'm going to give you an equation that involves the polar coordinate. Sketch r equal to 2 means sketch all the points, every possible point, whose polar coordinate satisfy r equal to 2. So it means that no matter what theta is, I want to sketch all the points such that this is 2, regardless whether theta is. So what are we going to get? Question addressed to you. circle with radius 2, and Lori is absolutely correct, because now I'm not emphasizing, basically, I'm emphasizing all the point. What is R? R is the distance between the pole and the point. So now I'm asking you to sketch all the points such that the distance from the pole to this point is 2. All the points that satisfy this condition. Oh, this is nothing more than a circle. It's a circle of radius 2. So R equal to 2. That's what we call a polar curve, because the condition is given on its polar coordinate. It represents very simply a circle of radius 2. So in general, of course, we can generalize. R equal to a constant represent a circle centered at the pole, that's the center, and with radius 2. Okay, question number 2 along the same line. So I will start with very simple. I want you to sketch the following curve. Theta equal theta. Now the condition is given out theta. Pi over 4 are positive or equal to 0. So what am I after? It means I want you to sketch all the points whose polar coordinate satisfies the condition. Theta has to be pi over 4. And the R has to be positive. So I will again want you to think about it for a minute before we draw, and I always appreciate answers on the chat. What do we expect to get? So I want the point, theta is pi over 4. So in my mind, I'm interested in those points. 1, that's for R, pi over 4. 2, for R, pi over 4. That's really what I'm thinking of. That's exactly what I'm thinking of. And 0, pi over 4, because I'm allowing, and so on and so forth. 3, pi over 4, etc. These are the points in my mind. And a half pi over 4, of course, for R. So what do I get when I start sketching all those points? Sketch them if you have a piece of paper in front of you, and then let me know. To start sketching the point, that's what I'm interested in. All the point, the theta is fixed, but the R is changing. So what determines theta? Anybody? A line in the first quadrant over. Anybody agree with Lori? Let's sketch this point. 0, pi over 4, that's that point. 1, pi over 4. It means we're starting with, I have to draw the point. That's pi over 4. That's 1, pi over 4. All those are in polar. 2, pi over 4. 3, pi over 4. Means I'm really getting all the point on this line. So this is a line. All the point on this line, that their theta is pi over 4. They have to be on this line. So this is nothing more than a line. It's not a line, it's a ray. Ray, it means it's not the whole line. So that's just nothing more than a ray. So it's the line, or as your classmates say, it's the line in the first quadrant determined by the angle pi over 4. Now let me take the following. I've got to do the same thing, but I'm going to take away the restriction on R. So now I will allow R to be positive and negative. So question is, I would like you to sketch the following. All the points whose polar coordinates satisfy theta equal pi over 4. I remove the condition that I had previously. So here I insisted R positive. Now I remove this condition. And how will this affect the picture? First, let us take several points that satisfy this condition and then put them together and draw the curve. Okay. All right. Who would like to pitch in? And what's the difference between this and the previous one? Let us take some points. I will take some points to satisfy. So 0 pi over 4, that's a point because that's the only restriction I have on the point. I want only the theta. So r can take any value it wants. So this is another point. This is a third point, and etc. I did not put any restriction on r. I did not put any restriction on r. It means I will allow r to be negative pi over 4. I will allow r to be negative pi over 4, and so on and so forth. So when I want to draw those points, so this is the polar axis. That's where I start measuring my angle. That's why it's called the pole. That's where we start measuring. So all the angles are pi over 4. So this is pi over 4. So I'm picking the 0. I'm picking 1 pi over 4. I'm picking 2 pi over 4, and so on. But now I allow r to be negative. So minus 1 pi over 4. Where will it be? This is 1 pi over 4. Minus 1 over 4 is going to be in the opposite quadrant. This would be minus pi over 4. Be careful, this is in polar coordinate. This is in polar, it's crucial. Minus 2 will be right there. It's the one opposite to 2 pi over 4 in the opposite quadrant. Minus 3, and so on and so forth. So theta equal pi over 4 right now is actually the whole line. It's not anymore the line in the first quadrant, like for r positive. You only pick up this piece of the line. When I don't put any restriction on r, I will pick up the whole line. So for me now, the equation of this line, that's the important, the equation of this line in polar coordinate is theta equal pi over 4. That's the equation of this line in polar coordinate. In Cartesian coordinate, it's different. But in polar coordinate, the equation of this line is theta equal pi over 4. So now lines through the origin will be actually written in a nice format in polar. So if I take this line here, let us say this angle from here to here is 3 pi over 4, then this line here in polar coordinate, this equation will become theta equal 3 pi over 4. So now if I ask you to sketch the line given by the equation theta equal 3 pi over 4, that's exactly the line you get. So that's a different way of writing the equation of the line by using the polar coordinate. Okay. Now, one more question. I want you to draw the following region. So now the question is, draw all the points whose polar coordinate are theta, satisfy the following conditions. I want theta between pi over 3 included and 2 pi over 3, and I want the r between 1 and 2, for example. So I want all the points are in theta that satisfy those two conditions. So basically, for example, a typical point will be like between 1 and 2. For example, r is, let us say, 1.5. That's a point because the r, that's the r. And a typical theta, for example, pi over 2, because pi over 2 is between those. So I want all the points that satisfy this condition, and I want you to think about it yourself and draw it in front of you before I draw it here. So first ask yourself, if you want r to be 1 and between 1 and 2, where your point should be. R is the distance between your point and the pole. You want the distance between 1 and 2. So where should the point be? Okay. The distance is between. So if I take this as the circle of radius 1, and I take this as the circle of radius 2, my point at least should be here. That's one condition that it should satisfy, because its distance to 0 has to be between 1 and 2. So it has to be in this ring. That's the first condition. So R between 1 and 2 represent, in polar coordinate, represent this ring. Right? It's very easy way to represent a ring is to express it in terms of polar coordinate. Part 2. R is positive in this case, because R, I gave you R between 1 and 2. I want the angle between pi over 3 and 2 pi over 3. So now theta equal pi over 3. R is positive, so I really don't care about this piece. So that theta equal pi over 3 with R positive. And theta equal 2 pi over 3, kind of, with R positive. So I want, so this is pi over 3, and this is 2 pi over 3. So I want my points to be in this ring, and I want it also to be between those two lines. So my region would be actually this piece right there. That's the region in polar coordinate. And one of the most important use of polar coordinate is basically to describe regions which are circular in nature. Means if I have this region here and I ask you to describe this region using Cartesian coordinate, it's really become very hard to do that. But if I want to describe this region with polar coordinate, it's actually fairly simple to describe this region. Okay. So I will stop at this note today. Please do the homework. It's not going to be hard. Your exam is next on Wednesday. Your final exam is on Wednesday. It will be between 10:15 and 12:15. So make sure you have those 3 hours absolutely empty, nothing in them. The review I will put on Blackboard, which I will put it probably in very soon. I almost have it. It's actually a combination of review 1, review 2, review 3. So they're the same questions. I will add some of the new material. So you basically can get started because you have review 1, review 2, and review 3, but I will put them in one bundle. And the solution, I will not rewrite the solution. Problem from review 1, I will refer you to review 1. Problem from review 2, I will refer you to the answer from your review 2. I will, however, put the solution for questions which is the new material that I do not have answers to. And how many hours did you say it will be? 2 hours. That's really the regular exam. It's 2 hours. Okay, I will probably give you a little bit more because of the issue of uploading and downloading and all this stuff. So you will have plenty of time. You always do actually on your quizzes. So please get started. And I remind you that I have office hours. You guys are not coming. Please do. It's your last chance to basically ask me any questions that you have. Okay, so the review will be on Blackboard very soon, hopefully in 2 hours at the latest. The answers, the old stuff will not be because I already have the answer from them. The new stuff, it will be. Okay, and that's it for today. I'll see you guys tomorrow. Bye.